Hello everyone. In this session, we will discuss fifth lab program from Machine Learning Laboratory. The lab program statement is to write a program to implement the naïve Bayesian classifier for a sample training dataset stored as a .csv file. Compute the accuracy of the classifier considering few test data sets. So first we'll see what is naïve Bayes classifier. Naïve Bayes is a statistical classification techniques based on Bayes theorem. It is one of the simplest supervised learning algorithm. Naïve Bayes classifier is the fast, accurate and reliable algorithm. And it have high accuracy and speed on large data sets. So next we'll see why it is called naïve Bayes algorithm. It is called naïve because it makes the assumptions that the occurrence of a certain feature is independent of the occurrence of the other feature. So that's why it is called naïve Bayes classifiers. So Bayes theorem, which is very important for naïve Bayes classifier. So here this is a Bayes theorem formula what we use for naïve Bayes classifier. So here the Bayes theorem is stated as probability of the event B given A is equal to the probability of the event A given B multiplied by the probability of A upon probability of B. So that is the formula what we use for as a Bayes theorem formula. So next we'll see one example. So we'll take an example to get some better intuition. So considering the problem of playing tennis. So here so we classify whether the day is suitable for playing tennis given the features of the day. The columns represent these features and rows represent individual entries. If we take the first row of the data set, we can observe that it is not suitable for playing tennis. Okay, so the attribute features, so attribute names here we have taken outlook, temperature, humidity, wind, and here the target value, that is nothing but the class label, or here we can take it as a class label, nothing but a play tennis, whether it is okay to play tennis on these days. Okay, so that is what we are taking here, the data set. So here we can observe that the first data set example, it is not suitable for playing tennis. So if the outlook is sunny, temperature is hot, humidity is high and wind is weak, we cannot play the tennis. Okay, so this is the data set we are taking. We are taking 14 training examples here, and we have some positive and negative training examples based on yes and no value. Okay, so these data sets we are using for the classification. So next, so here we will have two phases. One is the learning phase. So we'll be learning some information, or we'll be learning something from the training examples here. So here first in the learning examples we have to calculate the probability of playing tennis. Okay, so means the probability of playing tennis means the number of the class which is belongs to yes. So we have to calculate that probability. So here the total out of 14, there are 9 training instances which belongs to class yes. So and total number of training example is 14. So 9 by 14. Next we will calculate probability of playing tennis, means not playing tennis on those days. So that is which belongs to class no. So here there are 5 the class label with the no, so 5 by 14. So we'll calculate the probability here. Then what we will do, we'll take each instances, a training instance, and we will for each attributes in that training instance we'll be calculating a probability. Means that particular attribute value belongs to or which belongs to class yes, what is the probability, and if the attribute which belongs to class no, what is the probability. So here for each attribute value we will be calculating these probabilities. For the first attribute outlook, we have three values: sunny, overcast and rain, and these values which belongs to class yes and which belongs to class no. So all these probability we need to calculate. So like this we have to calculate for other attribute also, that is humidity, temperature and wind, and for both the class yes and no class we have to calculate the probability of belonging or probability of including this attribute value for the class yes and class no. So like this we need to calculate all the probabilities. So then we have to calculate the probability for the test data. So next here in the test phase for the tennis example, we'll take one new instance of variable values, means new test data here. So that is x dash. So here we are taking outlook value as sunny, temperature is cool, humidity is high, wind is strong. We are taking all these attribute values and we want to classify this new instance either to class yes or class no. We have to classify this. So for that what we have to do is we need to calculate a probability table or lookup tables for all the probability for these attributes belonging to class yes and class no. So like this we need to calculate all the probability of for the outlook attribute value sunny belonging to class yes. So that is 2 by 9. So like this we need to calculate all the probability, and then finally we need to use the map rule, that is maximum a posteriori probability rule, means we'll be finding out the most probable hypothesis. So for that we use this formula, means we'll multiply all these probability of this attributes from the new data set, and the probability value, the belonging to class yes and probability value belonging to class no. So we'll compare both the values, which class probability value is more, means that training instance belongs to that particular class. So here the probability of new instance belonging to class yes, which is less than probability of the new instance belonging to class no. So that means the new instance belonging to class no, that is having more probability value. So that means the new instance belongs to class no. So like this we have to classify the data set into a class. Okay, so this is the example. So same approach we use in this program also. So this is the algorithm what we use for naïve classifier. So here we are passing two parameters, training data and test data. So here each instance x is described by a conjunction of attribute values, and a target value v can take j in a finite set of values. Means here we have to consider each attribute values from the training data, and we have to calculate a probability of belonging these values to that particular target value. Target value means class labels. Okay, so for each value j in target, estimate the probability of the target value, means the class value. So probability of having class yes and probability of having class no. So all these probabilities values we need to calculate. Then for each attribute in the training example, estimate the probability of attribute value I, which means for the given class vj. Okay, so for each attribute value we need to calculate probability values, then classify each instance as per the rule in the equation. So finally we need to calculate means these by using this, means we need to multiply all the probabilities of attribute value from the new instance or from the test data, and finally we will get the probability value. So which class is having highest probability value, that is nothing but V, that is based on naive Bayes, denotes the target value output by the naive Bayes classifier, and that target value, that particular instance or the new instance or the test data belongs to, and that will be returned by this classifier. So that will be the class to which that new instance or data set belongs to. So this is the program we are implemented for 5th lab program. This is the implementation part. So here first what we will do, we will import NumPy library. NumPy is an open source numerical Python library. It contains multi-dimensional array and matrix data structure, and it can be utilized to perform a number of mathematical operations on arrays such as trigonometric, statistical and algebraic routines. And we use this in Python language. NumPy aims to provide an array object that is up to 50 times faster than traditional Python lists. So that's why we are using NumPy here. The array object in NumPy is called the ND array. It provides a lot of supporting functions that make working with ND array very easy compared to Python list. Arrays are very frequently used in these kind of in data science project, where speed and resources are very important. So that's why we are using NumPy here. So we'll import NumPy library and then we import maths, because we need to perform some mathematical operation like calculating probability, calculating accuracy and all. Then we import CSV, because we are taking the data set in the form of CSV. We need to read those CSV file. Then we have import PDB, that is nothing but Python debugger. Okay, so next I'll explain the functions used in this program. So we have a function that is read data. So we need to read the training data set. So here this is a function for that. So here we'll be reading the data, the CSV file as a CSV file, and we'll be opening this file in a read mode. So then the CSV.reader will read this CSV file and it will copy that into a data reader. Okay, so data reader. Then here this next function of data reader, this function we use to extract the metadata of the training data. Metadata means the column header or the attribute names. So we want to extract the attribute names. For that we are using next function. So here for our training data set, the metadata is nothing but outlook, humidity, temperature, wind, all those things. And okay, so this is a just to get to know what are the attribute names of this training data set. So next we'll create an training data set array. So then what we will do, we will, from the data reader, we will append row by row to this train data. Okay, so now we this particular function, after reading CSV file, it will return two types of data. One is training data and one is metadata. Okay, so this is the read data function. Next is split data set. So now here we are taking only one training data set or one file, and from this data set only we are splitting this into two types. One is training data set and test data set. So same file we are splitting. Okay, so how we are splitting? Based on split ratio. So based on some ratio we will split the entire training data set into training data and data testing data. Okay, so this is the function which will split your data set into training set and test data, and finally it will return in two forms, that is training set and test set. So next important function what we are using here is classify function. So here we want to classify the test data or the new instance to to one particular class, okay, based on the training data. So here we'll read both the training data and test data, and we'll take the size of these data, means how many training data is there, how many test data are there, so that we will read from these statements. Then we'll initialize few variables to get which are required to calculate a probability. That is count yes, count no, probability yes, probability of having no. Initially all these we'll take it as 0. Then we will just take the target, count and probability of whatever the training data we are taking. Next what we will do here, we will take the training data. Data is nothing but here training data, and the training data we will read the number of yes in the target value as yes in this training data, and we will count all these things. So every time when the yes is occurred, so the count yes will be incremented by 1. Next we will count the number of no's in the training data set. Okay, so then what we will do, we will calculate probability of having the total number of yes in the training data set by taking the count, the number of yes divided by the total size. The total size means the total number of training instance. Then probability of having the target value no, the same way using this formula. Then we'll just print those values. Okay, so the number of yes means class, and number of the class with the label no. So then what we will do, we have to calculate accuracy, means we need to take the test data and we need to assign or classify this test data for two particular class. So then we'll initialize one variable for accuracy to calculate accuracy for this classification problem. So then what we will do, we will just for each training data, we'll consider the training data, and we will calculate the training data and the test data, and we will take the number of no's in the test data and number of yes in the test data. Again we'll calculate the probability for the testing data. So once the probability of the number of yes and number of no's in the testing data, then what we will do, we will calculate the entire probability function, means the probability of having the each variables from or attribute values from the test data, and the probability of having the class label or target value no. Okay, so this is the function what we means a statement what we use to calculate probability of no and probability of having the class yes. Okay, for the test data. So this we are calculating for test data. Then next what we will do, we will compare the probability values of the class yes and class no. Means in the previous example I have told you which probability value is high, means the belonging to class yes or class no. Whichever is having more value, means highest value, though the training instance or test data belongs to that particular class. Okay, so here probability of belonging to class no is means the probability value for the class no is more greater than the probability of belonging to class yes. So that means what? That particular training instance belongs to class no. So no will be taken as the predicted value. If it is the probability of yes is having more probability value, means the prediction will be, means we will classify the test data to a class yes. Okay, so now if it is this is else part, we'll take the value, the predicted value as yes. So then what we will do, we will calculate the accuracy for the classification. So from the test data we will take the target value and we will compare whether the predicted value is equal to the training data set the target value. If it is same, then we'll increment the accuracy value, and then we will calculate the accuracy here. Okay, so accuracy of predicted value and accuracy of having the correct predicted value for the test data and the original target value from the test data, and we'll calculate the final accuracy and we'll display that in a percentage mode. Okay, so that is this everything which covers the classification part. So next, here it is nothing but we are just reading the data set, that is a CSV file. Then here this function, the read data function, will return metadata and training data. Once you read the CSV file as a text file, then what we will do, we will split that training data into two parts, that is training set and test set, by using split data set function. Then what we will do, we will consider the training data set. We'll just display the training data set and test data set using these statements. Then we'll call the classify function. Okay, to classify this testing data based on the training data. So now let's go to Jupyter Notebook and execute our program. So this is the program what I explained now. Okay, so here these are the function. So the execution starts from here. Okay, so first we'll load the data set. So this is the file location for the data set. Okay, in .csv mode. Format. So here the file name is tennis.csv. So this, from this location, the CSV module will read this data, and this calls the function read data function. Okay, then this function will be executed. So it will read the file in the as a CSV. Then it will take that file and it will separate the metadata and training data, and it will return the metadata and training data. So once I execute this, see, after this I'll just print the attribute names of training data. So just to know what are the metadata of this particular file. So attribute names of training data are outlook, temperature, humidity, windy, and answer. So these are the column headers or the attribute names what we are using for this tennis data set. Okay, next what we will do, we will split the data set. For that you have to give the split ratio. So here I am giving the split ratio as 0.6, means 60% I will take it as a training data set and 40% I will take it as a test data set. So I will pass this parameter and the training data into this function, split data set function, and this function is going to divide this training data set based on the split ratio. It will return training set and test set. Okay, so this function will return a training set and test set from after splitting the data set for this split ratio, 0.6 split ratio. Then what I will do, I will copy this training set into an array. Okay, array of training data set. Then I will just display this training data set and testing data set. So these are your training data set after displaying the training data set. So here we are using 0.6 means 60% training data set and 40% test data set. So totally we have 14 training examples. So here 8 training example will go to the training data set and 6 data set will go to the testing data set. So after displaying this, what we are doing, we are calling classify function for this training and testing data set. So now the control will go to the classify. It will call this classify function and it will first it will calculate all the probability values for the training data set, and it will calculate the probability of having yes and probability of having target value no. Then based on this, next it will call the test data set. Again for that also it will calculate having the test value, the attribute value which belongs to the class no and which belongs to class yes. So based on that it will also calculate the probability of values of attribute values of test data, and finally it is going to predict based on the probability value. So which probability is having highest value, based on that it is going to predict whether that belongs to yes or no class. Then it will calculate, it is going to calculate the accuracy for the predicted value and for the target value in the test data. Okay, so it is going to calculate the accuracy here. Then it will return the accuracy. So here you can see here, after splitting, the training data size is 8 and test data size is 6. Then it is just going to display this. The target value here we have two values, yes or no. Then count is 4 and 4, means the total number of yes is 4. So this is for training data set. Okay, training data set. So we are having 8 training data set, right? In that 4 training instance is having which belongs to class yes and 4 belongs to class no. So the probability value is 0.5. Okay, so then we will, after taking the test data value, we will be displaying this, means this is for the test data. 6 values, 6 training instances are there in the test data size. So here these are the prediction value. Okay, these are the prediction value and these are the original target value from the data set, and based on this we will calculate the accuracy. So here the prediction value is no, but here the target value is yes. So like this. So here these two values are wrong. First and 3. The prediction value is different from the target value from the given data set. So based on that it is going to calculate the accuracy. So here accuracy is 66.66. So this is the program, and here you can change the this one split ratio also. Here I am taking 0.6, right? So now I will change to 0.5. I will take 50% of training, means the data set as a training data and 50% as a test data. So now I will run this program. We will see the values now, output. So here, see here. Okay, I have taken the split ratio as 0.5. So totally there are 14 training data set, right? Now it is 7. There are 7 training data set and 7 test data set. So training data size is 7 and test data size is 7. So here this is the probability. From the training data size we have 4 training instance belong to class yes, 3 belongs to class no, and this is the probability calculated. And this is for the test data or the test data set. So here the accuracy what we got is 57.14. So this is the accuracy for the classification by using naïve Bayes classifier. So this is what I explained. So here this output is based on the split ratio 0.6, and for the split ratio 0.6 we got the accuracy 66.66. Okay. So that's all about 5th lab program. Thank you.